Great. Thanks for joining, everyone. I'm Rachel Neugarten. I work in the Moore Center for Science here at Conservation International, and I am thrilled to get to present to you all something that is kind of the culmination of my 7 years here at CI. Obviously, there's a big team behind everything that I do. Several of them are sitting in this room. Dave Hull, Pam Collins, Paul Turner, and others have been involved in this work. And we're also collaborating with partners at the Natural Capital Project, Mark Mulligan at King's College London, and several other groups. So I'm actually going to have you start off by doing a little visualization. For those of you who were in the Moore Center retreat last week, we did this already, but it takes a couple minutes, and I thought it would just be a nice lunchtime meditation, okay? So if you're not in the middle of eating something, please close your eyes. And, don't close your eyes quite yet, because I don't know how to work this yet. I think I have to click on the screen. Okay, so visualize a happy place for you in nature. This is where I was this past weekend hiking in West Virginia, Seneca Creek Falls. All right, so now really, for real, close your eyes. Picture yourself in your happy place in nature. All right, imagine invisible lines connecting you to the river or lake where your water comes from, and further to the wetlands, forest, and mountains where that water trickles from originally. Imagine dozens of lines to the farm fields and pastures and ocean where your food, coffee, and fish grow, and to the pollinators, soil, and coral reefs that fostered that growth. Imagine the mangroves that take the force of the storm, the trees that suck carbon dioxide out of the air, and the marshes that soak up the floods and hold back the soil. Now imagine a map of all the places that sustain you. Now imagine a map of all the places that sustain every person on Earth. Now imagine a future in which governments, businesses, and local people, empowered with this map, all agree to protect it, recognizing it is in their own enlightened self-interest. You can open your eyes now. So we're all dependent on nature. On top of this, we're facing a rapidly changing world. The population is growing, species are going extinct, the sea is rising, the weather is getting weird, people are getting hit by storms, droughts, floods, and famines more often and more severely. We need a map to tell us which places can sustain humanity in the face of this uncertainty. Right now, this map doesn't exist. So there's no way for us to point to the places sustaining humanity and advocate for them. Governments are planning blind, businesses cannot reduce risks to their supply chains, communities cannot safeguard the places they depend on, that their children depend on. Until now, science hasn't been able to provide us such a map, but now we can. We're creating one. And that is what this project is about. Okay, so in December 2020, nearly 200 governments are going to get together in Beijing, China, for the UN Convention on Biological Diversity 2020 Conference of Parties, or COP. The governments are going to set the conservation agenda for the next 10 years. So this process will influence hundreds of millions of dollars in conservation spending by governments, by major donors, by NGOs, and by civil society over the next 10 years between 2020 and 2030. There's an NGO policy coalition of 8 organizations who have agreed to work together on setting aggressive biodiversity targets to inform this post-2020 agenda. They haven't agreed on what those targets are, but they've agreed to agree. And they want everything to culminate in what they call the 2030 goal or the 2030 mission, which will be a focused, quantifiable, communicable goal so the world can clearly understand the value of nature and the role that the Convention on Biological Diversity plays. So this is sort of parallel to the Paris. Everybody's heard of Paris and what is the target? I don't even remember, 2 degrees target. Yeah, so it's a simple sort of easy to remember target, even though I didn't remember what it is. But policymakers know we want to avoid more than 2 degrees Celsius change in global climate. So there's a whole bunch of activity around what should these targets be. So there's some groups advocating for bending the curve, which means if biodiversity is sort of in a curve decline, they want to bend that curve back upwards to avoid further losses. There's some groups who are advocating for 30 by 30, they call it, meaning 30% conservation by the year 2030. There's a global deal for nature. So there's a lot of sort of action and movement in this space. The groups have all proposed their own ideas of what a global target could be. Some of them are talking about a net gain for nature, like the Nature Conservancy. Some are talking about reversing the loss, like WWF. CI is talking about the nature that we need. So there's a lot of groups that are thinking about how to conserve biodiversity into the future. But until now, nobody's really looked at the nature that humanity needs, so the ecosystem service side of the equation, the benefits that nature provides to people. So that's the question that we're asking in this project. Where is the nature that we need, humans, to sustain us? There's another policy opportunity happening right now, which is the UN Sustainable Development Goals. So countries have committed to reducing poverty, ending hunger, and a number of other goals towards sustainable development. And Pam Collins and others here, Dave and Will Turner and others here at CI, have looked at the role of nature in achieving these goals. And they found that roughly, 47% of the goals or the targets within the goals are supported by nature in some way. So those green bars indicate sort of how much of that goal depends on nature and natural ecosystems for its achievement. And the important, oh, hello. We just got video. Okay, all right. So the important point to make here, that's nice, maybe she'll come back later, is that nature sustains a lot, is really critical to underpinning a lot of these goals, not just the ones that themselves are about nature. Do you have a question?
Are we holding them to the end? It's okay.
No, go ahead.
How are they calculated?
How are they calculated? So how are those bars calculated?
Yeah.
Well, there's a massive spreadsheet that contains all 169 targets, and each of those targets gets evaluated for ways in which it could be achieved and potential outcomes of its achievement, and what are the roles of nature in supporting the achievement and the potential outcomes. It's based on a series of expert opinions and literature review. So definitely something for discussion, more than a 100% correct, quote unquote, the answer, but important at least have something to foster that discussion and have a framework to hang the discussion on.
Are you able to give an example, like quality education is 10%? What would be the example there?
So the other point is that those percentage numbers refer to the number of targets within a goal that have a dependency on nature. And so the way Goal 10's targets are written, only about 10% of those targets depend on nature in some way for their achievement. That doesn't mean that education mostly doesn't need nature. What that means is the way targets were written for that particular goal, they mostly focus more on the human elements of education.
So education includes education in nature. So taking children out or graduate researchers out into nature and studying the ecosystems and the nature, wildlife and so forth. So nature does sustain our educational system. That was the example you're looking for. But you guys can also follow up if you have specific questions about this paper. Every time we click off the screen, I lose my clicker. Okay, cool. All right, so others have published in this space looking at more specific links between things that come from nature, which are on the bottom, food provision, water provision, raw materials, genetic resources, and which of the SDG goals and targets. So there's also a lot more specifics here. Pam has that massive spreadsheet that she mentioned. So basically, the idea is that nature does underpin a lot of these SDGs in ways that policymakers don't necessarily think about when they're thinking about reducing poverty or supporting education in their country. And we want to make sure that that doesn't get lost. And there's also documentation of that in the published literature. So I'm just going to provide some definitions before I get into sharing some of the preliminary maps. So natural capital is the stock of biodiversity and ecosystems that provides a flow of benefits for ecosystem services that support human well-being and economic activity. Within natural capital, the concept of critical natural capital is the subset of all natural capital that provides benefits that cannot be substituted or replaced. So what does that mean? It's things like globally significant biodiversity, sources of fresh water that provide the sole supply for a human population, wild sources of food that provide a safety net to people in times of crisis, natural places that are part of a culture's identity, and there may be many other examples out there. So understanding the links between natural capital and the SDGs will help us inform kind of ultimately the conservation agenda for the next decade. So this concept actually comes from the economics literature. The idea that there is something called critical natural capital is part of the idea that, you know, you can basically replace certain things from nature. You can replace, right? You can synthesize medicine, you can treat your water supply with physical or chemical methods to clean your water, but up to a point, you can only do so up to a point, and there's a cost. So the idea of critical natural capital is that at some point that nature becomes so critical that it's either too costly, too expensive, or literally just cannot be replaced. It's non-replaceable. So not to get into the weeds, but I just thought if there was anybody interested in sort of the economics behind this. So from this paper, Farley, in 2008, they talk about region 1. So critical natural capital, there isn't sort of a yes, no answer for what's critical and what isn't. It's usually more of a continuum. So when you've got healthy stocks of nature, you've got a sort of replaceability. You can replace that capital with other forms. Nature can kind of renew itself. In region 2, so getting sort of more towards the critical side of the curve, capital stocks are less resilient and approaching a threshold beyond which they cannot spontaneously recover from further loss or degradation. And then in region 3, capital stocks have passed critical ecological thresholds. Marginal values are essentially infinite. So this is really where we're getting into that sort of irreplaceable nature. And the restoration of natural capital stocks is essential, right? So this is the sort of the economics perspective on what critical natural capital means. What we're interested in is where is this stuff? Why do we care about that? Well, we need maps to identify, again, where nature is supporting those SDGs, to inform the CBD post-2020 process. But ultimately, what we want to do is guide scarce resources to the places they can be most effective and support place-based conservation on the ground, right? That's what we're all about here, is sort of helping policymakers, decision makers, communities, businesses do this work on the ground in the places that are most critical. We know we can do this, right? CI has a long history of identifying important places. This is the original biodiversity hotspots map. It drove over $1 billion in conservation investment globally into these places that were identified as extremely threatened, having large numbers of unique species, and high diversity. We also, over the past 7 years, have learned how to map places important for other benefits to humanity. So we've led work in Amazonia, in Liberia, in Madagascar, in Cambodia, and in Asia Pacific on mapping important places for ecosystem services across a number of different benefits that nature provides to people. And we've learned along the way how to do this better and better. We've partnered with lots and lots of collaborators, ecosystem service modelers. We've learned how to use remote sensing data, satellite data, cloud-based computer processing, which has improved recently. So our goal on this project is to do that, but globally. So we're scaling up. Part of my interest in this work is we were doing this work kind of one country or region at a time. So in 7 years, we were able to map 7 countries or regions, which is great, but CI works in 26 countries around the world. And while that's great job security for me, I didn't think I had 26 years to devote to mapping critical natural capital one country at a time, as much as I love doing that. I'm going to go to grad school and get a PhD, so I needed to do this faster, right? So I needed to figure out how can we provide some of this information to everybody all around the world at once, not only our CI programs, but in other countries. So our goal here is to map 12, 13, the number changes every day, ecosystem services globally. The reason it's changing is we're learning about data availability. Some data is forthcoming, some may not be, our ability to model. So this work is happening in real time. Our goal is to have preliminary maps within the next couple of months. Our framework for all of this is basically thinking about the way that nature provides the services, the way that people use or benefit from those services, and then the final concept is sort of the critical piece, which is where are those services really non-replaceable, non-substitutable. So again, this framework isn't anything new. It's been published before, but the idea that services are provided by nature, even if they're not being used. So potential ecosystem services are all of those benefits being provided globally. So an example here is all the woody biomass on the planet that exists in trees or shrubs or other woody plants. So that map in dark brown shows woody biomass. And then where are those benefits actually being used by people? We don't actually have that data globally, but we can estimate based on where people are. So this second map shows woody biomass that's accessible to people in some way. So those are considered realized. They're not technically realized because we don't actually know how much and where, but I joke, we call it like potentially realizable because they're there and somebody has access to them. And then the final one is critical ecosystem services, which are the benefits that cannot be substituted or replaced. And we don't, again, know necessarily where things are critical, but we can use a proxy, for example, ecosystem services that are benefiting the world's poorest populations. So taking a subset of these areas where people are probably critically dependent on that woody biomass for fuel and for resources because they don't have other options because they're poor. We know it's not perfect, but it's sort of the best we can do at a global level. Okay, so now I'm going to share some preliminary maps with you. None of these are finalized yet, but just to give you a flavor. So in terms of carbon storage, this is probably the best developed research. Monica Noon has been helping me put together global carbon maps, which include above ground, below ground, soil organic carbon from forests. So that's what this map shows. So the yellow and getting into red areas have the highest carbon biomass in forests. Does anybody know where the highest carbon biomass in forests is? This was actually new to me.
Southeast Australia?
Yes. We'll need that. You're leading the climate strategy, so I should hope that you would know. But also the Pacific Northwest. So for our Seattle friends on the line, if there are, we've got globally high forest biomass carbon there, and Southeast Australia, as Will mentioned, in eucalyptus forests, right? So very cool map. This map also includes soil carbon. So there's tons and tons of soil carbon up in the Arctic region, in the what's it called? The permafrost, yes, the tundra, yes. And then we're going to add mangrove soil carbon, which does exist as a global layer to this. And this map, by the way, will also be the map that the Climate Irreplaceable Ecosystems team is using as underpinning. So we're coordinating with them. So what we call critical natural capital for carbon or for climate, they call Climate Irreplaceable Ecosystems. So that's a parallel initiative in the Moore Center and the climate strategy team.
Rachel, is yellow high?
Yellow is high, yes.
Okay.
Sorry.
Thank you. So
okay, coastal protection. So we know that ecosystems help protect coastlines. This is a photograph of Madagascar, where very sadly they've lost most of their mangroves protecting their coastline, which really affects them when they get hit by cyclones, which they do 3 to 5 times a year, unfortunately. So these are some preliminary maps. I had to zoom in. This is the Philippines and Southeast Asia. Coastal habitats are really, really tiny and really, really hard to see at a global scale. So it looks a little pixelated. The raw data is actually finer yet than even I'm showing here. I've shown it at 10 kilometers resolution, just so you can see it. But basically, red areas are where habitats are providing what we think are critical protection, where there's people that live there. There's storms, wave height, and wind direction indicates that that area is probably getting hit when there's a storm. And then a number of other factors here, the habitat itself, distance to the coastal shelf, the coastal geomorphology, which is what the coastline is made up of. So there's a whole bunch of things that go into this map. This work was done by the National Capital Project team. They're a partnership at Stanford, WWF, the Nature Conservancy, and University of Minnesota. Same map, but for the Caribbean and Florida.
Rachel, is that square kilometers?
They're 10 square kilometer pixels, yeah. The raw data is actually much finer than 10. I think it's even less than 1, perhaps. So they've run their, this is based on the INVEST model, and they had to tweak it in order to run it globally, but they've run it globally at the finest resolution that they could.
Are the values people or?
The values are red areas are just where habitat is playing a role. So higher the greater the protection provided by nature, the more red the color. And there are people included on this map, so if there's no people, there's no protection. So it's not just anywhere there's habitat. Okay, so that same team has run the global an INVEST model globally for nitrogen. So nitrogen is an important water pollutant, and so this is a map of where ecosystems are reducing nitrogen in water supplies. And it's also looking at where that's benefiting people. So areas that are important for reducing nitrogen are areas where you have a really high nitrogen load in the first place. And so places with a lot of agriculture are highlighted here. So this is vegetation's role in reducing nitrogen into streams. So you can think of it as a proxy for the role of ecosystems in supporting water quality for drinking water specifically. Again, red being the higher value here. They've also run pollination globally. So ecosystems provide really, really valuable benefits to crops in the form of pollination. They've included a whole bunch of input variables here. They've looked at only agricultural crops that actually are dependent on pollinators at all. And then they've looked at where natural ecosystems are nearby. And they've looked at 3 different things: energy, so in terms of total calories, folate, and vitamin A, thinking that some people may depend on food for undernourishment, so the total calories, or malnourishment. So certain crops actually provide key nutrients that people need. So they've really tried to think through not only where is agriculture, but also where is agriculture that may be benefiting people in terms of their food security. Marine fisheries, obviously, also critically important for food security globally. Reg Watson and others have painstakingly built a database of where fish catch is high globally. So dark blue areas are where there's more fish catch. This one is total catch. We've also divided it into industrial and non-industrial. So non-industrial catch might be small scale. That might be really important, especially for people who are poor or vulnerable, don't have other sources of protein. And they've included both reported and, to the extent they can, unreported fishing. So it's the most comprehensive database on fisheries that there is globally. Forage for livestock, so another key aspect of food security and indirectly poverty is where animals graze and where nature is supporting those grazers. So this is a model from Mark Mulligan at King's College, where he's looked at dry matter productivity, basically where is nature producing biomass, and then where are livestock, and that includes maybe a dozen different kinds of livestock, everything from cattle and goats to ducks and chickens. Nature also supports, of course, our construction materials, and for many, many people provides fuel wood. So this is a map of just that potential service. We don't yet have the realized and critical ecosystem service maps. This map just shows biomass. So this is from that first framework where I showed you, just woody biomass globally. And then we'll look at where people actually are and where poor people actually are able to access that as a proxy. Another group of analyses that was led by the Nature Conservancy is looking at tourism, specifically coral reef tourism. So they've modeled dollar values generated by coral reef tourism globally. And it's an index, and it's based on a lot of input data and assumptions about where people are diving and how much money they're spending there. But it was the best the experts could come up with in terms of a map of places that are providing a lot of tourism. So darker brown values are high. The size of the points has been grossly exaggerated so you can see it globally, because again, coral reefs are very, very small, but you can zoom in and get more detail. And what we're planning to do with this is look at not just where people are spending a lot of money, but where those livelihoods are probably critical for local people, particularly poor local people. So again, we're trying to get at that sort of critical dimension. If you are a wealthy person and you go scuba diving, that benefit is wonderful and it has a value to you. It may not be critical to your livelihood and well-being, but it may be critical to the person who lives there, whose jobs and income are supported by that diving. So we're going to try to parse that a little bit. Okay, and then there's a whole bunch of things that we're working on that I can't show you yet today. Flood regulation benefits from nature, wild food and other wild products from nature, access to nature in terms of recreation and mental health, and diversity of cultural services. Then, woo, back up. Okay. Then we're going to try to put it all together, right? So we're going to try to have some maps of potential services globally, realized services globally, and services that are critical to the best that we can, and integrate them all in not a single map, but probably three maps in the end. And we're going to write a paper. We're going to provide all the data, open access to the extent we can. Now, when somebody's given us a data set that they've restricted, we're not allowed to share it. But anything that we have produced ourselves will be made available, probably through the Resilience Atlas and maybe through Google Earth Engine and maybe ArcGIS Online, maybe a couple of other places. We want to try to make it as available as possible. And we're going to provide policy recommendations for the post-2020 conservation agenda, as I mentioned. That's a photo of the team. We were all together in Minnesota recently working hard with some of our NatCap colleagues. So that's Dave and Pam. They're wearing sunglasses, and Steve Pulaski in the front. So this is us hard at work. Doing science is not always so sexy and glamorous as sitting next to a waterfall and pondering your links to nature. We do a lot of whiteboarding. This is Justin Johnson, who's a key sort of ecosystem service modeler and whiz kid with coding. So he was coding up scripts while Steve and Becky and I were whiteboarding. We're going to try to bring it back to the sort of economics concept of critical ecosystem services. We're going to develop graphs. Some people like graphs, some people like maps. The graphs can also help us think about where to draw the line between what's critical and not, by thinking about how much each individual place contributes to nature and sort of where that saturates globally, which will hopefully help us answer the question, how much nature do we need? Not only where is the critical nature, but also how much globally is contributing. And of course, we do a lot of drinking. Also very important to the scientific process. Building social capital. So there's a whole lot of people who we have consulted or who have participated in workshops. So just to say that there's a core team working on this, but there's a lot more people out there who have provided expertise and data in many cases. And that's it. So thank you very much to my colleagues. This is all of us at yet another beer garden in Minnesota. Yeah, maybe we would do more science if we did less drinking, but we'd have a lot less fun. And with that, I will take any questions. Sorry, would you like Dave to bring it back around to CBD post 2020?
No, I thought you did a great job summing it up at the start. So.
Okay. Yes, Michael.
Other than the carbon stocks in Australia, what have been some of the most surprising findings?
Good question. Oh, and looks like we have comments online. So all those maps are preliminary, so I'm kind of reluctant to say what is where just yet. One of the challenging things with ecosystem services is that over time, basically ecosystems produce the flow of benefits, but those benefits are only realized where people are. So where you have higher levels of realized service may not actually be strictly correlated to where nature is providing more service. It may be more related to where people are, where you have more people, and where demand is higher. So that map of nitrogen retention, for example, shows part of our problem, which is that you show these really high service areas in places that are highly modified agricultural areas. It doesn't mean nature is doing more work in those places, it just means that's where the demand is. And so telling that story to a policymaker becomes a bit challenging, because you may end up showing a map of very modified habitat as providing your highest value globally for the service. So that's just one thing we're going to have to think about. And over time, you'll actually get increasing need for that service as population grows, consumption patterns change, as climate changes. And so it may look like your service areas are increasing in places that are actually quite degraded, just as a result of higher demand in those places. And so it won't necessarily drive you to kind of your most intact habitat where the higher potential services are. So that's why we wanted to make sure to include the potential services map, because that really shows areas where even if those benefits aren't accruing to anyone today, they're probably going to become really important tomorrow under climate change.
So on that point with like climate refugees, will you be able to make some predictions on where people might be moving to make up for resources they've lost?
I would love to do that, but no, not in this project.
Okay.
I think that's a really important
But is there
question.
something potential with this data that if not you, other groups would be able to do?
Yeah, so again, if you think about the potential services map, and if you actually had a model of where people might move under climate change, and I think maybe you guys have done some work in this space. I know Will and David published a paper on that.
Yeah, so just where in terms of the initiatives process, Giacomo Fideli is trying to put one together, albeit it's nowhere near as well developed as this one, but we'll be looking at natural security. So that notion that where ecosystems are blowing apart, people may well then get the heck out of Dodge. So, but it's hard to do. Yeah, you have to model basically the social system as well as the ecosystem and the interaction between them. But this is, let's say, one step on the road to trying.
But we're not trying to model where people are going to move under climate change. Yeah, but it could help maybe inform. If somebody else did that part, ours could help inform where nature is providing benefits.
So the potential maps could speak to areas where there are ecosystem service potential that are not yet realized, but there's some caveats in there.
Okay. And the climate irreplaceable ecosystems map would be the same as the carbon stocks map?
Yeah, that one's not developed yet, but it would be a combination of high carbon ecosystems that are manageable by people. So there's a challenge with places like the permafrost that almost no matter what we do as the climate warms, those areas that carbon is going to get released into the atmosphere, versus a place like a tropical rainforest where you actually can do something about the management of that carbon. And then the third criterion is if that ecosystem were lost or degraded, it would take more than 30 years to recover. So it's a recoverability criterion. So that map is just one of the three criterions. So it has to have high carbon, but it has to also be manageable and recoverable. So there'll be a sort of subset of places on that map that will become the climate irreplaceable ecosystems map. Is that right?
Yeah.
Yeah. Yeah.
So these maps are, say, from the production side of it, right? What we have, what we need, but is there another, like, say, consumption side of it? So I guess to get at the shortfall of how much we really need, because I guess, like you mentioned, because a user of a service may not be present at the site where the service is provided. So how do you account for that?
So in all of the realized service maps, we're trying to account for the demand or the consumption of the service, but differently. So I gave the example of we know the nature is accessible to people. We don't know that they're actually using it because we don't have that data. But all of them try to account for that differently. So the nitrogen retention one assumes that if there's nitrogen load in that place, it's going to flow into your water supply, which is going to contaminate your drinking water. So the assumption is that anywhere nature is reducing that, and you've got people drinking that water. So it's like, I think they their beneficiaries, like all rural populations downstream of that nitrogen influx. They're assuming that reducing that nitrogen is being consumed, the cleaner water is being consumed. And then the coastal protection layer is where people are, where they live within a certain distance from the coast and also elevation, and so forth. So they're all treating the consumption side differently, and many of them are proxy variables. Mark Mulligan, and actually both Mark Mulligan and the NatCap team have thought about unmet need. So they've actually tried to quantify sort of what is nature doing, and also what is the total demand. So either per capita, livestock, like how much does a cow graze per head, and then they've multiplied that across all the livestock in the world, and then tried to figure out, whether the demand is greater than the supply. So they've attempted to account for demand the best they can.
Input data is kind of the tricky thing.
Yeah.
It's like sometimes you know where people are, you know what they're consuming, you know what they need. Then you can make those assumptions and start mapping stuff. If you don't have that data, either you make assumptions or you just say, look, I don't know.
And the assumptions are often wrong. You get your water from the groundwater source from the well and not from the surface water. But the model can't model groundwater, can only model surface water. So that's a challenge too.
And this being global scale makes it actually really hard, because there might be really good numbers for a particular region where a particular study was done, and then you're off to the races. But you don't have that globally for most things. Yet.
So I saw Bambi, and then I know there's questions online. Yeah.
I think my question builds off of hers. There's like a question of like how the trade flow kind of features into it. Because if you're looking at poverty locally, we're kind of missing how dependent the world is on that particular thing. And so I'm just curious, like, what were you not able to model or map that you really wished you could have?
Yeah, so many things. But you're exactly right. Yeah, so trade is a real challenge. So, and Will has been advocating from the beginning so that's why we have the three categories: potential services, which may become important in the future; realized services are realized to anybody anywhere in the planet. So if you think about total crop production or total fish, so that map of marine fisheries, that's total fish pulled out of the ocean anywhere. So that you can kind of think of like that's probably benefiting someone somewhere, maybe a very wealthy person in Singapore, or maybe a very poor fisherman in Raja Ampat, but it's probably benefiting someone. But we aren't able to necessarily link where that fish is being consumed. So trade and transport is a big problem for a lot of these maps. And then the critical piece is where we do try to sort of say, probably if you're really poor, probably you're benefiting from things more locally, and then making some very gross assumptions, which we know are probably wrong at a fine scale, but maybe sort of, generally true. People in Raja Ampat are probably fishing locally and eating fish from Raja Ampat. So that's the third category of maps. There's a lot of ecosystem services that we weren't able to map to. That was another piece of your question.
Yeah.
So lots of the cultural services, you just can't see culture from outer space. So you can't detect it with satellites. So it makes it a lot harder than things like biomass.
So that's just a really important point. We're not producing a map of the nature that people need. We're producing a map of some of the really important green stuff, but there may be other stuff out there, or there is very likely other stuff out there.
Yeah, we know that we're trying to map 12 or 13 ecosystem services, and some of the classifications have 80 total ecosystem services. So we know we're missing a lot of the links between nature and people.
So this is like the bare minimum.
For a few services, it's the bare minimum. Yeah. Okay, so we had questions.
No, you don't.
Okay, never mind. Anybody else?
I guess I'm a little curious if there's a plan to adapt these per sustainable landscapes and seascapes at CI, and how that can sort of help define, like from a conservation finance standpoint, where we decide to invest.
Yeah.
I know these will be per ecosystem service. Is there a way to overlay them?
Yeah, so you can definitely overlay this with SLS, but the caveat is that the scale might not be good, and the data for your SLS is probably better locally available in some cases. Although it's been surprising how often we've done this work at national or regional scales and realized actually there isn't anything because nobody's done the ecosystem service modeling. So some of this data is very fine resolution, but you would definitely want to sort of fact check landscape by landscape. I wouldn't recommend just zooming in on an SLS and using our data as is, but it can provide a starting point. And the framework we hope would actually be applicable. So you could ask the same set of questions, maybe with local data. So if you've got potential services for carbon, you've got potential services for fuel wood, you would do a similar analysis, but with better data locally. So yes and no. Anything else?
I guess I have one more question.
Yes.
So the maps that you were able to do on a country by country basis, how do you when you think about what you were able to do on a country basis versus what you're able to do at a global scale, like if we had the map at the country level, should we use that one and not the global?
Yeah. Yeah. So Max Wright always says, use the data that's available at the scale that you're making the decision. So if you have national scale data, for sure. And for several of those SLS, by the way, we have done this work at a national scale. So Liberia, Cambodia, Madagascar, some of the SLS are covered by those. Amazonia includes, is there an SLS in Amazonia? Maybe not. Anyway, yeah, so where that data is available. But that said, those maps that we produced at the country scale, sometimes because we didn't have anything better, we still had to use global data and models. We did try to use local land cover data. If they had data on where cities and people and dams and agriculture was, we used that because those are the beneficiaries that were locally available. But we're working in a fairly data poor context typically at CI. Developed countries have much better data typically than developing countries. So a lot of the countries where we did this work, we ended up relying on global data and models anyway.
You have a question for Scott.
Oh. Scott says, so far, have you been able to identify any or a few factors that explain emerging trends on where the highest concentration of ecosystem services are? Presumably forest cover would be one, but perhaps others. So yeah, going back to my comment earlier, the highest concentration of ecosystem services are where the people are. That's really, what a lot of these maps show. It's not perfect because obviously there's some global benefits like carbon, and there's benefits that flow like water or fish that move from place to place. Forest cover does tend to drive a lot of these models, and so it looks like forests provide a lot of ecosystem services, which of course they do. But that's also because that's something we can map really easily. You can see trees from space. You can see loss of tree cover from space. There's actually, again, very modified habitats tend to provide a lot of services to people in terms of food, hunting, agriculture, grazing, timber and fuel wood, wild forest products, medicines. And so if anything, my takeaway from a lot of these maps is if you do conservation of their most remote intact habitats, that's great for providing certain services like carbon and long-term conservation of biodiversity, but you're actually missing a big part of the picture, which is agriculture or sort of semi-modified savanna habitat that are providing, and the ocean that may be heavily fished, but those areas are providing a lot of benefits to people. Okay. Thanks very much for joining.